So this is G484 homework booklet question 13. We've got a container with a mole of an ideal gas, volume V, pressure P. We've got a diagram to show the relationship between PV and the absolute temperature T. Straight away I hear the words ideal gas, I'm thinking PV equals nRT. So with PV equals nRT, I've got PV on my y-axis, I've got T on my x-axis. So where am I going with that? I'm going to actually deal with this alongside part 2, and if I use my very best iPad handwriting just to get y equals mx plus c available, and then we can see I've got PV is y, I've got T is my x, so m, the gradient, is nr. So the gradient is nr, but in this case n is 1, so that's going to give me a gradient of 8.31. So the volume of 1.5 moles of an ideal gas at minus 40 degrees is 2.4 times 10 to the minus 2. The gas is now heated up at a constant pressure, P. Calculate the volume of the new gas. So what I've got here is constant pressure. I've got Charles' law. I can think in terms of V1 upon T1 is V2 upon T2, and that's fine as long as I get my temperatures into Kelvin. So minus 40 is 233, 250 degrees is 253. Log my numbers in, rearrange it, and I get a new volume of 0.0538. Getting these temperatures right is an M mark. In other words, if you don't get these temperatures right, you're having none of the 3 marks on this occasion. So, as ever with these gas situations, we've got to be thinking in terms of absolute temperature. So then they ask me what is the value of the pressure P. I'm going to have to go in and use PV equals nRT. P is what I'm after. The volume, I've gone with the initial volume. You could have just as well gone with the final volume. Equals N, we were told as 1.5 moles. R, the constant. T, just be careful here that you use the temperature, 233, that went with the volume. I used 2.4 times 10 to the minus 2. You could, of course, have done it for the higher temperature and the larger volume. That would have worked fine. We end up at 1.21 times 10 to the 5. What's slightly interesting about this is once I'd got that value of pressure, I could have, in fact, if I'd have done this whole question first, I could have done the volume using PV equals nRT of part 1. Would have been a slightly roundabout way of doing it, but I did have the information to get the pressure, find what the pressure was, and then I could have done a full PV equals nRT there. But much easier when you can is just to use those proportionalities that you've got, use the bits that you actually need to use. So that was G484 homework booklet question 13.